morning, everyone. I want to say thank you so much for being in attendance for the SAEOPP 21st Annual McNair SSS Scholars Research Conference. My name is Kenneth Randall. I prefer to be called Chase, my middle name. I'm a computer science major at Georgia State University. And so today my oral presentation will be on finding the association rules of 311 complaints in San Francisco zip code. And so for the next 15-20 minutes, the outline will be, we'll talk a little bit about the motivation, a little bit about the technical background, the research aim, the method approach, results, conclusion, and then we'll have some question and answer. So a little bit about the motivation. As a computer science major, we know that big data exists everywhere. We see it normally in the business industry or in the financial industry when it comes to credit score. In the business industry, we see it as far as market analysis, analytics, reaching out to customers. And so for me, I wanted to do big data for social good. And so we know that big data exists in about everything that we do. It's in cars, it's in phones, roads, power lines, and many other things that we never really thought of as computers. For example, the microwave. And you have smart TVs, we're starting to have smart refrigerators. And so all of those smart items, when they connect to the internet, are generating data. And so the data speaks volumes about our collective behavior and also our society. So what type of hidden patterns can we discover when we analyze the data? So a little bit about the technical background. When we have more big data, that's going to generate more issues, which creates the need for more solutions. And so when it comes to solution, there is a data mining technique called, there are three major data mining techniques. One is called association rules, the other one is clustering, and the other one is classification. And we know classification from the bioinformatics area where they do classification in regards to analyzing people for cancer and things along that nature. For the purposes of this research, we use association rules. And association rules helps us to uncover relationships between seemingly unrelated data in a transactional database, a relational database, or other information repository. And so what that means in a business industry, let's say, for example, a customer comes into a store and they buy coffee. Well, if they buy coffee, there's a likelihood they're going to also buy sugar and cream. And so from a transactional database perspective, we know that those three things go together. So now the next question becomes, well, what's the confidence level? What's the likelihood that if a person buys coffee, they're going to buy cream, versus if they buy coffee, they're going to buy eggs? There's a stronger likelihood, and we call that a confidence level. So what's the confidence level of coffee and cream versus coffee and eggs? And so that's a part of the association rules that helps us to better understand a relationship data. And also it helps us uncover patterns. So the research method will be, the research method we use was an IBM created data set. We use Hadoop. Hadoop is a platform just like Windows. In the data mining industry, there are different platforms that we use, and so most people are familiar with Windows, but in the data mining industry, Hadoop is the platform that we use. We also use the San Francisco 311 data set, and we also use citydata.com, and then we use the Apriori algorithm. Apriori algorithm is an algorithm specific to the association rules. So here's a screenshot of the IBM curated set, and as you see, there's several different apps that I could have deployed in regards to analyzing the data. The San Francisco data set is an open platform, open portal that San Francisco makes available to its residents so that residents can be a little bit more familiar with what the city is doing to be responsive. And so that data set has several different subsets. There are crime incidents. There's also 311 complaints. 311 complaints are the service requests that people will make. There's also film locations. So if somebody's doing a film, they capture that data, put that also in the data set. So here's a screenshot of what the San Francisco data set looks like. It's broken up into various categories. You have economic and community, city management, transportation, public safety. And so right there under the screenshot here, we see 311 data set. So that's the data set that we specifically use. We could have used any other, but for our purposes, for our research purposes, we use the 311 data set. So I want to break real quick and talk about the Apriori algorithm so that people can get a feel for what that looks like. So here you have a situation where we have a transactional ID identified by here. And so there's 5 different transactions, and each of those alphabets represent a respective transaction within that transaction database. So we created an item, a database list. So we have the transactional ID. So then the next question becomes, what's the confidence level? So we want the item to exist at least 60%, because for purposes of research, confidence level is 60%. So when you look at the next slide, all the A, D, I, and U, they only appear one time within that database. So that means that they have a less than a 60% chance of occurring. So because they have less than a 60% chance of occurring, we exclude that item in our research purposes. So now we find the items that have a greater, that have at least a 60% chance of occurring, and that's what L1 indicates. Those are the items that have at least a 61% chance of occurring. So then we take those single items, which could have been coffee or whatever the case may be, and we pair them now with another item. So when we do the pairing, we scan again and say, does this pair exist at least 60%? So all the items that are in blue, they of course don't appear at least 60%, so now they drop out. So when we look at it, we see EK, EO, and KO exist at least 60%. So in that particular case, we know that the pair, EKO, has a 60% chance of occurring. So that's the Apriori algorithm, and that's how we use the Apriori algorithm when we analyze the respective zip codes. So now the question becomes, now that we know how to use the Apriori algorithm, the research aim is, how do we find what association rules can we find in 311 complaints vis-a-vis zip codes? And again, we're using the Apriori algorithm where the transactional IDs are actually the zip codes, and then the incidents that occur are the transaction items within the respective zip codes. So the first thing we have to do as far as the method approach is we have to prepare the data. That means loading up the data sets, filtering the data, and also making certain assumptions. And when we say filtering the data, we're trying to, so if someone, if someone files a 311 complaint, sometimes the zip code may not be present. So in that case, the data has been filtered. Here's an example of an actual 311 complaint. This is an example of the zip codes. And so here are the incidents, and as you see, some incidents are reported at a higher frequency than other within a respective zip code. For this particular zip code is 94102. So in this zip code, we see that street cleaning has a high prevalence of being reported. So once we analyze all 27 zip codes, we find that the trending items are abandoned vehicles, general requests, and graffiti on private property. So there's a 90% chance that when someone complains about an abandoned vehicle, they're also going to complain about sidewalk. And that's intuitively true because most abandoned vehicles are right near a sidewalk. Again, when someone's making a general request, whether it's for trees, they'll say, oh, the tree's down, and by the way, there's a sidewalk complaint. So those are the respective zip codes that generate the higher amount of incidents. So the conclusion and contribution is, the reason that this is important when we analyze the big data for social purposes, it allows cities to allocate their resources. So if there are particular zip codes that have higher sidewalk incidents, then you can allocate more manpower and more resources in that particular zip code versus other zip codes. And so that's one of the reasons that this particular research is important, because it helps them better manage their money. And again, we just used the 311 data set. It could have been crime stats, it could have been education, it could have been public health. So whatever the data set is, we can use that respective data set and help the city better manage its money, because nobody wants their taxes raised. And so these are my references. And again, because this is public domain and public issue, you don't have that many people who are actually interested in pursuing this type of big data analysis, because it's not related to financial transactions. Most businesses have the money to do that type of analysis, but public entities, they're so busy trying to maintain the municipality, they don't necessarily have the infrastructure to do the type of data set. So that's one of the items that could be used for further research to potentially help other cities. And again, we use San Francisco, but there are many cities that don't even have a data portal, so they can analyze that type of data and better utilize their resources. Again, I want to thank you for your time. My name is Chase Randall. I do have some cards if anyone wants to talk a little bit more after the question and answer in regards to the research and analysis. Are there any other questions or concerns?
I just want to say I really liked I mean, how you broke down the charts and everything and your data, and then you just at the end brought it all together and broke it down, what it all meant.
Thank you, appreciate that. Any other questions or concerns?
Why did you choose San Francisco particularly for your?
San Francisco is one of the most IT cities, and when it comes to providing data sets open to the public. When you talk about analyzing data, the question becomes, what data can you get access to? And if you can't get access to it, you can't analyze it. And so San Francisco is leading the way. San Francisco, Seattle, a few other cities, New York, they're leading the way as far as making their data sets available to the public. Most cities don't want their crime stats open to the public, but San Francisco actually makes that information available. And it's user-friendly. When you saw the screenshot, very user-friendly. I could have chosen any one of those data sets. I saw somebody's hand over here.
Question about the 311 data set, that's more of a generalized.
It is. Yes, generalized services, so it could be for, mainly geared towards public works.
Okay.
Mainly geared towards, and again, I just chose that one because at the time crime was kind of hot, and I was like, I'm not going to do crime, so I wanted to do something general, but it could, of course, apply as well to the crime stats. Any other concerns? Questions? Yes, ma'am.
You said at the end of your project that this information or how to analyze this information can be used and help towards like city financial and everything.
Yes.
Do you think it also can help using towards like setting programs up to where it can limit crimes like this? Or?
That's correct. That's correct. And again, the crime stat data set could have been analyzed appropriately, and they could have used, again, we're talking about allocating resources. So if there are any particular zip codes that are hot zip codes versus other zip codes, then again, it can help them allocate resources versus, just kind of putting people out there. They're better managed. And then also because you're able to analyze the data, I mean, again, I looked at zip codes. I didn't break it down to time slots. I looked at zip codes and dates. So, you could drill down even further and say, what time of the day do we see peaks? What days of the week do we see peaks? And then that way, again, if they had the resources, you could analyze it better and better utilize your manpower versus someone spending 8 hours in this area, they could spend 3 hours there and the other 5 here because that's a hot spot. Any other concerns? I want to thank also my mentor, Brent Duncan, who helped me with this research.